Yeah, thank you very much, and welcome to my presentation. I'm giving this presentation instead of Han. He actually wanted to give it, but he is sick. So there are other viruses than COVID, so he can't be here. I'm going to happily do the presentation of our Information Systems Journal paper entitled Natural Language-Based Detection of Semantic Execution Anomalies in Event Logs. Quite something, right? So let's talk a little bit about anomaly detection and what this is all about. So if you have not ever heard about anomaly detection, so anomaly detection is typically when you have an event log and you're interested in, well, analyzing this event log and identify things that are maybe non-compliant or require your attention, but you do not have a model. In practice, this is quite common, right? So for those of you who are into conformance checking, we like to believe that it's a very common scenario to have a log and a model, and you can simply take these two artifacts, put them into an algorithm, and then you get all the insights you need. In real life, that is a bit more complicated because these models are typically hard to get, but what you may have is the log. And there are these anomaly detection techniques that essentially try to detect unexpected behavior or compliance issues. Yeah? And how this works, or how traditional techniques work, is they basically look at the numbers, right? So they have a frequency-based approach. I'm oversimplifying a little bit. These techniques are quite advanced, but are statistics-based. Means, in essence, if something is common, it's okay. If something is not so common, it's not okay. Right? I'm oversimplifying just a little bit, but that's basically the point, right? So you use statistical means to check what is infrequent, what is frequent, what are things that are peculiar, and based on that, you make the call. If you look at this very insightful example, this is basically what, again, simplified, what you would do, right? So you have a trace, ABCD. It's on purpose ABCD, so you don't look into the semantics of these activities. You just have a sequence of events. And then you realize, well, ABCD occurs 10 times, and ACBD occurs just twice, and ABCE 5 times. And you would, on a trace level, then say, oh, something that only occurs twice, and maybe another trace occurs several thousand times. That's something we should look into. Maybe this is an anomaly. Now, you get my point. This is something you can do, and I think these techniques are very useful, but we are, Han and also me, and the PhD students we have are mostly working in the NLP semantics area, and we were wondering, isn't it possible to leverage this and to actually go more into the meaning of things, right? So here we just look at sequences, which is fine, but we thought just because something is rare, it doesn't mean that it's wrong. Yeah, so you may have these exceptions in processes. Yeah, reiterating the payment for 15 times, which is maybe something that you should look into, but it might not be a compliance issue or something. Yeah. So this is basically that was the starting point. So we thought, okay, is there any mechanism we can use to find anomalies that do not build on the concept of frequency? Okay, now I'm there. So what's the idea? So what we wanted to do is to take the meaning of events into account, and we put it that way in the paper, to detect anything in the log that simply doesn't make sense. So I have an exercise for you. It's a non-graded assignment, no worries, but let's let you look at this for 10 seconds. Maybe you can spot anything. Louisa? Yes, so here something is approved before it's checked. And you may come up with a context where this makes sense, but intuitively, right, so you look at it and say, okay, we should probably check the order before we approve it. Okay, that's trace number 1. How about trace number 2? Yeah. Yeah, so there are a couple things, yeah. So let me, that we identified. And here we have a couple things, right? So we have approve and reject. So we cannot approve and reject something the same process instance. It doesn't make sense. You hopefully agree with me on that. And after it was rejected, then the product was still delivered. and a delivery was completed but never created. So these are things, as a human, you look at this trace, and of course this is a simple trace, so you can grasp it, but you look at it and feel, okay, that's not right, that doesn't add up. And the question is, can we somehow make a machine recognize these things? And it's obviously complicated, but this was the main idea of the paper. And we set out to do that. So what do we do? So starting point was to build up what we call a knowledge base. So we use two types of resources. I'm going to explain a bit more detail: linguistic resources and process model collections. So NLP is really interesting. So I did my PhD in this area on the intersection of NLP and BPM like 9 years ago, I think. Back then, 90% of the things that we have now did not exist. So it's really growing extremely fast. So I think Dina mentioned, the first talk mentioned transformers and these things, right? So these are very recent developments, extremely powerful. There are lots of resources you can use. So the basic idea here was to say, okay, we have linguistic resources. I'm going to show you an example where we can detect some relations and also process model collections, because process model collections, in the ideal case, show us what should be happening. We can discuss whether this is true, but this could be an assumption. And we populate a knowledge base, and then, well, that's something you have to do once. You can reuse that, of course. And then on the event log side, what do? Well, we have to parse it. So there are different techniques available for doing that. You dissect these labels in the event log. And what we do here is very simple. We just try to identify what's the verb and what's the object, and we can treat these things separately. Okay. And well, then we basically compare things, right? So we look into the log and see, okay, what's there, and then we compare it to our knowledge base. And then we can detect different types of anomalies. And what we cover in our paper are 3 different things: missing events, redundant events, and incorrect orders. So let me elaborate a little bit on that. I'm not going to take up all the time, no worries. Let you enjoy the weather soon enough. Okay. Sorry, I have to click here. So on the linguistic side, we use something that's called verb ocean. So verb ocean is something pretty interesting. It captures relations between verbs. There's an example, and I hope you can read it. So what you see there is that on the left-hand side you have invent, and on the right-hand side you have manufacture. And what verb ocean captures is that there are certain relations, certain happens before relations. Yeah, so you invent something, and only once you have invented something, you can build it. Once you have built it, you can redesign it. Once you have redesigned it, you can manufacture it. Once you have invented something, that's the upper branch, you can also patent it. Once you have invented something, you can also create it. So you have these happens before relations, and that is very interesting because this is quite generic. And if you look at languages, I mean, obviously, languages are big, there are many words, but verbs is a so-called closed class. Yeah, so the number of verbs is not really, I mean, there are new verbs once in a while, but not too many. So this is a countable set of words. So if you can capture relations among verbs, you have quite something in your hands. So there are 3 types of things in this verb ocean resource. Happens before, yeah, so something comes before, comes before manufacture. There's enablement. You can, so if you make something, you can sell something, makes sense. And there is antonymy, yeah, so opposites. Yeah, if you penalize, you cannot reward, reject, accept, these kind of things. From the process side, we decided to, on top of that, also learn typical process patterns by looking into process model collections. We used the famous or infamous BPM AI collection, which is not necessarily, from a qualitative perspective, the best thing there is, but you can identify things like that, right? So you have create order, check order, and then there is a decision between accept order and reject order. And that decision tells you, okay, obviously these things exclude each other. And the idea is to, or what we did, is we analyzed the entire collection, and of course you get some weights, right? So one process model would say, well, these things are exclusive to each other. In another process model, they would not be. So we count that and take this into account. Yeah, so I will not go into too much detail now. Okay, what do we get? Essentially, we have a knowledge base that tells us for 2 actions relating to the same object, what should hold? And there are three things. Yeah, so there's this order relation that you can see there. So basically, A2 should not happen before A1. There is this exclusion relation, meaning A1 and A2 should not co-occur. And there is a co-occurrence relation, meaning if A1 occurs, A2 should occur as well. Okay. So what do we get, just to give you some numbers? From WordOcean, we extracted about 6,000 records, for about 4,000 order, about 400 co-occurrence, about 1,500 exclusion relations. And we integrate this into this knowledge base with high confidence scores because this is a trustworthy source. For the AI collection, we got thousands more, but obviously they sometimes contradict each other, so we used varying confidence levels for those relations. Okay, this is basically the main thing. Once we have this, the idea is that we can use that knowledge base to detect and to parse the labels and then detect anomalies that relate to the same business object. So let's look at a quick example. So you have this trace create order, accept order, check order, create delivery, and complete delivery. And if you break it down to the action pairs, you see that, well, we get those, create accept, create check, accept check, and create complete. Yeah, the first relating to order, the second relating to delivery. Well, now you can simply look into the knowledge base and check, okay, for delivery, is create and complete violating any of these relations that we have captured in the base? Yeah? And in this case, we may, for instance, recognize that accept check violates the relation check and accept that we have in the knowledge base. And that's essentially the core idea that we had. And we did some experiments, obviously. First with synthetic data. So we used a couple of the models from the AI collection, not all of them, because only very few of them were actually correct in the sense that you can automatically process them so they can be simulated. So about 3,000 models we took, and we generated event logs from those and inserted noise into them. Yeah, so that basically allowed us to know what is something that, we insert the noise and we wanted to rediscover this noise. So we wanted to check, okay, what of the noise that we inserted can we actually identify? Yeah. So that was the idea. And then we can essentially measure how many of these anomalies we can detect. We focus very much on precision because it's clear that in terms of recall, our approach wouldn't be too impressive, because if you consider what kind of noise you insert into a log could be completely random. And obviously we can only detect those patterns that have some kind of, that violate our semantic rules, and there might be simply patterns that don't. Yeah, so that's also not surprising. It's also not our ambition. We have we ran a lot of different configurations of our approach, so there are many things you can tweak, and we also combined our approach with some statistical approaches because we already suspected that a hybrid approach combining the semantic and the traditional statistical perspective would make a lot of sense. Yeah? So that's the one side, and then we also checked some real-world event logs, basically to provide some feeling, okay, is there anything from the logs we all know, right? So you all know the BPI 2012 log. Sometimes you're desperate, you're taking it for all the experiments that you have because there's nothing else, but you know it, right? So, and the idea was, okay, if we can find in these well-known logs anomalies that people can relate to, well, then it's at least some, we provide some insight that people can relate to. Yeah, so there, the idea was simply to check whether we can find anomalies. There was no gold standard available because how could we get such a gold standard? What did we find? So we found that it works pretty well, or surprisingly well. So depending on how we configure this, we have a quite high precision. So those, meaning those anomalies, so those things we label as anomaly are actually anomalies. Yeah, up to almost 80% precision. The recall is not too impressive. We don't even report it in the paper, but it was really not the focus to say, okay, if we insert thousands of anomalies that do not relate to any semantic pattern, we obviously cannot find them, but those we find are actually anomalies. Yeah. So most of the anomalies we find were exclusion violations, most precise we are with order violations. And if we compare this to the frequency-based approaches, we achieve higher precision but lower recall, not a surprise. But it really makes sense to combine these things, because some of the things we find are anomalies, but they're not infrequent. They might be frequent, or they simply could not be identified by these frequency-based approaches. To give you at least some examples, so you can get related. So what we found in the BPI 2012, for instance, there are many cases where cases are cancelled and then later approved and accepted. And we accounted for loops, right? So that is accounted for. So this exists, and maybe if you know the log well, that doesn't surprise you, but these are things that actually occur. Or plans being received before they actually had been requested in the BPI 2015 log. Yeah, or preparations being finished before they began. So there are really lots of these patterns. Just to give you some examples. And important, and that was also our, what we suspected, many of these patterns are actually have varying frequencies. So some have a low frequency, some have a high frequency, which, yeah, supports our point that the combination makes sense because, well, simply looking at the statistics might not be enough. So now I don't know how fast I was, so I'm sorry that we end up in the rain probably before the coffee. Everybody's so quick today. So just to conclude, so what we wanted to do and what we did is we wanted to tackle anomaly detection from a completely different angle. Yeah, so we thought, okay, semantics is something that we should use. It's complementary, and we defined an approach that does that. We did find that this is a promising idea. We basically liked the idea so much that we tried for a long time before it worked. But it's complementary. It's clear that this as a standalone solution will not beat the existing frequency-based approaches, but in combination, it's really useful. Yes, so what else can we do? Well, we can further obviously develop this semantic anomaly detection perspective. There are additional resources we could potentially use. There's ConceptNet, there's VerbNet, so there are all kinds of linguistic resources out there. We haven't looked into all of them. What we haven't done, you may have noticed, we haven't looked into, so we only looked into intra-object relations, right? So we looked just into order, yes, and order accepted and rejected. But it's obviously possible to also try to understand how do different object types relate to each other, right? So I have an order, and maybe I have, I don't know, a contract, something like that. How do these things relate? And that maybe we could capture that as well. We tried, to be honest, but we didn't have enough data to get anything useful there, so this didn't really help. There are other things you can use, deep learning embeddings, to detect the difference between regular and anomalous behavior. Then now we explicitly encoded the knowledge in this knowledge base. Maybe there is a way to do this differently. We haven't tried, but we believe that's possible, especially if you consider how massive the advancement in NLP are. It's quite impressive, I think, over the last couple of years. So this is basically our first attempt into semantics-aware process mining. This is, I think, how Han also framed this, his own research these days. I think it's a very interesting direction because it's complementary. It's not only looking into frequencies, it's not only looking into traces and control flow. It's sort of looking into control flow, but we really try to understand the meaning of what's happening, and I think there is much more potential in that direction. And having this said, I would like to thank you for your attention. The paper is available, both on my website and Hans' website. Of course, it's a preprint. We're not violating any copyrights. And if you have questions, feel free to reach out to me or to Han. Thank you.
Thank you very much, Henrik. And there are already questions. I don't know who was first. Okay.
Thank you. Thank you, Eric. It's really nice. Really, really nice work. I think there's a lot of potential on this use of verbocean, not only in process mining, but in process modeling as well. I was considering areas like process enhancement and process repair, especially for declarative processes. Like the notions that you consider happens before, enablement and antonymy. These are things that you have in declare. This is the things that you have in DCR graphs.
Yep.
So I was wondering whether you have also considered, because it's really difficult to find the proper constraints, and even for experts, sometimes you just miss those ones. So I was wondering whether you have considered exploring these techniques of yours in the modeling aspects.
We haven't, but now you mention it, I think it's rather obvious to do it. No, I think it makes perfect sense. No, I think it makes perfect sense. It would probably be, and that's what I mentioned also in the limitations, it would be interesting to then overcome this intra-object perspective, right? So then you could come up with generic declare constructs, you could do on-the-fly semantic modeling support, right? Hey, you have done this probably doesn't make sense, or have you considered adding this or that? I think it would be very interesting. Yeah, thanks.
Eric, hi.
Hi.
So, very interesting work. So, this relates, at least in my view, right, to trying to incorporate what I would call common sense reasoning inside process mining, right?
Yeah.
So the conjecture, for example, we wrote a position paper in this problems workshop with BPM, is that in many cases, if you ask a person that knows about the organizational domain, obviously, right, would tell you immediately whether something is an outlier or does not make a lot of sense, right? So now the question would be how much you can push this forward and how can you integrate these to have knowledge bases that you can use to do reasoning, right? So not just to detect that something is not as expected, but maybe then to infer things, right? So the examples you were showing, in some cases would, at least if you ask a person again, right, would indicate that you needed to switch to activities, right? So there was a time stamping problem. In some other cases, you may have just a missing step. In some other cases, that would completely make no sense, right? So yeah, the question is a bit how you can relate to that. Also, because I didn't completely understand, this is something I need to read, how much you have in this knowledge base already, or how much you need more, right?
Yeah, so there are different directions, right? So one thing is, of course, how specific the things are in the knowledge base. Right now, they're rather generic. You could use more domain-specific resources to fill the knowledge base, obviously, right? So I'm thinking of medical domain or something like that. But this would only be on the population side. And on the reasoning side, I think there could be much more done, right? Right now, it's very basic. We basically get these, essentially you have a bunch of anomalies that say this relation violates this relation. There's not much. We do not, at this point, we don't do much with it, right? And then as you've described, I think it would be very interesting is to then, maybe, I think what you described is then also how to fix it. That would be interesting. What I do not know is, how to take this further, or also, I mean, we cannot really encode any kind of knowledge in this knowledge base, right? So some things are domain specific, and there are a few people that know or have insight, and they, as you say, they look at it and say, well, this is a problem. Yeah, I don't know whether it's worth the effort of trying to capture this. But yeah, I think especially the reasoning direction would be really interesting. So to move from, I mean, it's something I think as a community that would be generally interesting to move from just analyzing to telling people how to do it better. This is something I get a lot from practitioners, right? So they spend thousands of years on Celonis, and they say, yeah, but our processes are still the same. The tool doesn't tell me how to do it better, and maybe we can go that way. I don't know. No. Thanks.
Hi, thank you for the very nice talk. I have several questions, but I will limit my So first of all, you are using general purpose models to detect the relationships between different terms, right, in the vocabulary in general. First question is, can it be affected by the context of applications? So for instance, two different terms might be related in one context or not in another one. So how it affects then your approach. And the other question is, you're considering traces of events. And in traces, you might also have loops. So, for instance, two terms that are not subsequent in common sense might be subsequent because you just have a loop. Are you considering this issue, and how are you treating it?
Yeah, so question number one was about the context. You're absolutely right that there might be different patterns for, so different meanings of a word, or different, maybe not even different meanings, but in a different context, it might be just different. So we do not account for that. We could by essentially, now we build on the word level, right? So that's, from a linguistic perspective, very lame, because you could use something more interesting, like an embedding, so you could actually differentiate different meanings of words, so that could fix it. Right now we don't. So we just look at the syntactic word, right? And if the scenario that you describe, if in two domains, let's say order has completely different patterns, that would be simply all in the knowledge base, and we would get sort of a weighted or maybe even inconclusive results. So that's something we do not account for. For the loops, we do account. So we check the model and check whether there is a loop, because if there's a loop, well, then obviously if you reject something, there might be an iteration and then you accept it, so we simply account for that. So the loops. Yes, yeah, so because we, in the quantitative evaluation, we generated the traces from the model, so we would know whether this results from a loop or not. Yeah.
Oh, okay.
Thank you. Very, very interesting work. I wanted to follow up on the loop aspect. So you say that you control for the loop. Does that take into account the viewpoint of, for example, like if you have activities at the header level and item level, and you have an item level that gets like checked and approved, and then another item level checked and approved, but then you can have like item 3 is checked and item 4 is checked,
yeah.
and you have item 3 is approved, and so I assume not, but you might surprise me. Do you already, or is this like future joint work, perhaps, that you also take into account that viewpoints that you know are very challenging with relational databases?
Yeah. So it's going to be disappointing. No, we do not. So right now it's just a syntactic object, right? So if that syntactic object was item 1 versus item 2, then we would detect that. But I think it's not complicated to adapt it so that, I mean, the logs we use are basically logs from the BPM-AI model, so they're very simple, they're not very technical, and they do not come with any additional interesting data. I think would be rather straightforward to take this into account, right? But that also then partially relates to the problem of, you know, whether these flat event logs are the right thing to analyze for these kind of patterns, because I think if you have several items, and then, yeah. But it
well,
would,
the item number would be like a data attribute.
Yeah.
It wouldn't be part of your activity or your event.
Technically would be trivial, right? To just then do this per item, but we didn't have data that would be on this level of complexity, so we basically ignored it. But I think, at least from my understanding, how you describe it would be rather simple to adjust it.
Okay, cool, interesting.
Hey, Henrik. I have a question that probably I just also could find in the paper, but because we have a lot of time and there's raining, I'm going to ask now. Just to be clear, if the model or the data in the event log, it doesn't mention accept order, but instead order has been accepted, if that would be the description, would you still be able to recognize that as?
So once again, what does the lock say?
So in your ocean, you have these ideas like accept has to come before, accept and reject cannot occur together. But in the event log, it mentions the label of the event is order has been rejected.
Oh yeah, that's not a problem.
Okay.
So these basic NLP twists are not a problem. No.
Okay. Yeah, then maybe what about the other way around? So I mean, this ocean, yeah, had to be created. So somewhere, someone had to find all these things and what are the relations and stuff like that. So could you also kind of find, include some findings from your analysis, then back into this ocean or so that is kind of growing or so? Is this an idea?
Yeah, it's a good point. So where the entire thought process started is, does it make sense to build up sort of a resource about process knowledge, right?
Yes,
so couldn't we just have something that, so when as a PhD student, I worked with WordNet. I don't know how many of you know WordNet, but it's so cool as a community to build a resource that then everybody uses, right? So this is so cool. And we were thinking about that. So I don't have a conclusive answer. Okay. Mm-hmm. I think yes. So some things are so specific to the notion of a process that you could play it back, maybe even with different relations. But I think at this point we do lack really good process model data. I think sometimes we have something, but then we cannot really use it. And this BPM AI is also, that we use that, is also a bit of a sign of desperation, maybe, because there is no public, there is no public repository we can use, right? For the event logs, we have something. It's also getting slightly dated, but for process models, it's not better. So the short answer, if we had something that would be really big and reliable, or at least in this relevant or from industry, I think it would be interesting to do that, to build something up like that.
Yeah, because I think this is the charm of this, to say, okay, well, there is some of these things available, and I do a check over my models. Yeah, okay, I still have to look at it if it's really a conflict or not. I think also I cannot directly say, but maybe it's quick, and I find some interesting situations that I can look into. That I think this is okay.
Exactly.
Mm-hmm. And how strong do you believe in label equivalence?
Label equivalence, yeah. You mean whether things are the same?
You're working on labels here, more or less, right? Pre-processed, possibly, but
it's not a lot of information, right? These tiny things. It would be would make perfect. So I think what would make sense is if we had a real log with additional attributes to basically go for embeddings that then include this additional context. Yeah. So I mean, we talked about context earlier today, so that would be good. Yeah.
Okay. Yeah, I don't see any more questions. So, okay.
Yeah, well, what about scalability once we start having labels that have more verbs? Let's say, like, I'm trying to pay a bill or something like that.
Yeah. Yeah, we can dissect that, right? So we can dissect it, we can analyze it, so that's not technically a problem, even if there are more verbs or more actions, even more objects, so that's all okay. It's hard then to determine the relation between these things for this particular label, but besides that would work. But again, like Stephanie said, it's not a lot of information. Check order is not a lot of information, and whether another check order is the same thing is of course context dependent, a strong assumption. Yeah.
Okay, last chance. Yeah, if not, then let's thank Hendrik again.
Thank you.